Hello everyone. This video shows you how to use PIE5 for hyperspectral quantitative application. The hyperspectral quantitative application group includes index toolbox and quantitative retrieval toolbox. Index toolbox. Hyperspectral remote sensing can form tens or even hundreds of narrow bands continuous spectral coverage over a wider wavelength range for each pixel while imaging the spectral features of target, which makes it possible to examine the response mechanism and physical mechanism of vegetation spectra more deeply. Therefore, it has become a powerful tool for vegetation monitoring and related fields. Following is the introduction of Vegetation Index. The Vegetation Index is a combinatorial operation of surface reflectance in two or more wavelength ranges to enhance a certain characteristic or detail of the vegetation. All vegetation intensities are calculated using high-precision multispectral or hyperspectral reflectance data. Radiance brightness and dimensionless dN values without automatic correction are not suitable for calculation vegetation index. Click Hyperspectral Quantitative Application Index Box, Vegetation Index, and the Vegetation Index dialog appears. Click the point and the Vegetation Index Toolbox dialog appears to select Import File. Select Import File in the file list or click Import File to import internal file. Click the point to pop up the Select Spectral Subset dialog. The spectral subset can be selected by securing the red box or manually entering. Click the point to pop up the file spectral subset dialog and the spectral subset in the brand list, and at least two brands need to be selected. Then click OK. Select the vegetation index to be calculated according to the need. Multiple vegetation incidents can be calculated at the same time. The generated multiple vegetation indices are in different brands of the same file. The default is to calculate all vegetation index image. After completing the setting, click OK. Set the path and file name of the output file. Click OK to perform vegetation index calculation. A linear inversion model based on the existing data can be established, and the brand number corresponding to the wavelength of model-independent or variable brand and corresponding independent coefficient can be determined. Click Hyperspectral Quantitative Application, Quantitative Retrieval Toolbox, Quantitative Retrieval. The Quantitative Retrieval dialog appears. Click Point, and Quantitative Retrieval dialog appears, which is used to select Input File. Select Input File in the file list or click Import File to import extra file. Click the point to pop up the Select Spectral Subset dialog. The spectral subset can be selected by securing the red box or manually entering. Click the point to pop up the File Spectral Subset dialog. Spectral subset in the band list, at least two brands need to be selected. Then click OK. Set the path and file name of the output file. Click the Parameter Settings to pop up the Parameter Setting dialog box. Set the processing algorithm, including raw data, first-order differential, and continuum removal. Enter the constant term of the inversion model, which is the value of constant term of the formula of the extract feature. Set the independent variable coefficient and independent variable. The set independent variable coefficient is the coefficient of the corresponding band in the model. Select the independent variable bands corresponding to the coefficient through the Select button. Click the Add button to add the selected independent variable to the independent variable list, and click the Delete button to delete the selected argument in the argument list. After completing the setting, click OK to return to the quantitative inversion dialog. Here, inversion of organic matter with reference to the following formulas. SOM equals 34,480 plus 2.029 times B144 plus 71.088 times B155 plus 7.396 times B57 dash 95.985 times B158 minus 22.185 times B71 plus 28.911 times B76. Click OK to perform organic matter inversion.